Now, there are certain examples based on the simple pendulum. When we use the term simple pendulum, again, main formula to be applied is T is equal to 2 pi under root L by G. And when sometimes the pendulum is suspended to the ceiling of lift and lift is moving up, then G plus A will be considered in the denominator. And if the lift is coming down, G minus A will be considered in the denominator. So these facts we are going to use in the examples based on the simple pendulum. Now, our first example is that is simple pendulum of length L and mass m is oscillating about vertical line, and the limits of oscillation minus phi to plus phi at the angular displacement the magnitude of theta less than phi. The tension in the string and the velocity of the bob are T and V. Which of the following relations is correct for the pendulum? So we have to identify the correct relation. So obviously by calculation only we can find it which can be the correct relation. So in the first option it is T is mg cos theta. Then in the second option T minus mg cos theta, that is equal to centripetal force. So it is taken as mv square over r, but r is L. So we have taken mv square over L. And the third concept is T cos theta is equal to mg. That is weight mg is equal to T cos theta, or weight is balanced by T cos theta. The magnitude of tangential acceleration when the pendulum is moving in curve at a point we draw a tangent. The direction of tangent is the direction of acceleration, and its value is AT modulus, that is equal to G sine theta. We can calculate it, but at this stage we have to remember it for using it in the numerical formula or the numerical question. So the pendulum is indicated here. That is weight mg is acting vertically down. Pendulum bob is moving between the two extremes. So we are finding that mg is resolved into one of the components, that is mg cos theta. The other component is mg sin theta. So T and mg cos theta balances, and angle between T or mg cos theta and the vertical position of pendulum bob, that will be taken as theta. From the figure, we find that T will be mg cos theta plus mv square over L. We are using mv square over L instead of mv square over R, because R and L will be same here. So mv square over R is the centripetal force. So normally we take mv square by R, but now because R is L, so we take mv square by L. Tangential acceleration is mg sine theta by m. So m will cancel off. It will become g sine theta. Hence, correct answers will be 2 and 4. So again, the same figure is given, and this figure is responsible for the calculation point of view. Now, our next question is, what will be the percentage change in the time period of a simple pendulum if its length is increased? So we have to relate the length with the period. So it is given as delta T by T into 100. This is a formula, and this will be half of delta L by L into 100%. And by calculation, it comes to be 3%. Now in the next question, the weight is 5 kilogram. A 5 kilogram weight is suspended from a spring. The spring stretches by 2 centimeter per kilogram. It means our total weight is 5 kg, but for 1 kilogram, the stretching is 2 centimeter. Obviously, for 5 kilogram, the stretching will be 5 times, that will be 10 centimeters. So if the spring is stretched and released, its time period will be how much? Where we can take G as 10 meters per second square. This value we take only when the other values are not given. Normally the value of G is 9.8 meters per second square. But however, for simplicity of the calculation, G must be taken as 10 meters per second square. Now, the main formula of the pendulum is 2 pi under root L over G. So 2 we have written as it is. Pi is 3.14 under root L over G. G is taken as 10 and L will be in accordance with the statement 2 centimeter per kilogram. So 1 kilogram is 2 centimeter. So 5 kilogram will be 10 centimeter, and 10 centimeters divided by 100. So 10 over 100 means 0.1. 2 centimeters. So it will become 0.02 divided by 10. And in all, the number will become 0.628 seconds after calculation. Now, next question is, a simple pendulum is suspended from the ceiling of a lift. Now, there is a lift and its ceiling that is connected to a pendulum. When the lift is at rest, its time period is t. With what acceleration should lift be accelerated upwards in order to reduce the time period to t by 2? So we have to reduce t to t by 2. So what should be the acceleration? While going up, we find we have to take g plus a. While coming down, we have to take g minus a. So the main formula is 2 pi under root L by g, and t over 2 will be how much? It will be t by 2 will be equal to pi into under root L over g plus a, or this will be 2 equal to g plus a over g. So if we add g and a, it will become 4g, or a will become 3g. So acceleration is 3 times the acceleration due to gravity. Now, the bob of a simple pendulum of mass m is oscillating with an angular amplitude of 40 degrees. The tension in the string at instant when its angular displacement is 20 degrees will be how much? So, we have to find the tension in the string at the instant its angular displacement is 20 degrees. The first option mg, then greater than mg cos 20, then it is less than mg cos 20, and the fourth is mg cos 20 exact value. So to solve this question, the tension in the string at displacement theta will be how much? So we have added the two forces. When two forces are in same direction, we add them. So it is mg cos theta added to mv square by L, where mv square by L is centripetal force. If theta is 20 degrees, then T20 minus mv cos 20 is calculated, which is found to be mv square over L greater than 0. So T20 is greater than mg cos 20, hence the correct answer will be the second option.